So I want to I really appreciate the invitation, Jonathan, to talk about this article. This was an article that I put together with my colleagues, Peter Pulsifer, who I asked to join and contribute a little bit to the presentation today. And also Matthew Druckenmiller, who's a fellow researcher at NSIDC, and Finn Danielson, who's at Nordeko in Denmark. And I'm going to talk a little bit about what we learned in putting this article together, and then give some examples. First, though, I will briefly, for those who don't know ELOKA, introduce the Exchange for Local Observations and Knowledge of the Arctic. So I am the current PI of ELOKA, and ELOKA is a program that's based at the National Snow and Ice Data Center. Peter Pulsifer was the former PI of ELOKA, and so he's bringing to this article and this presentation a lot of his background knowledge on the specific software tools that ELOKA has supported, as well as some that he's been working on from his new affiliation at Carleton University. And ELOKA has been around for some time now, and we work to foster collaboration and learning between resident Arctic experts and visiting researchers. And we do a lot of data management and user support. And we sort of look at the work that we do as having three elements that comprise what we call a community data management system. So one of the elements is sort of understanding, implementing, and helping raise awareness about requirements and best practices for ethical data management and collaborative approaches to data management with Arctic residents. Another aspect is building capacity and community to share knowledge and information, and to be able to undertake data management close to home for those communities who are based in the Arctic. And then the other aspect is collaborative data stewardship. And so this is really the work that we do to co-develop tools that support partners and projects in stewarding and sharing their data. And the article that Jonathan asked us to talk about was published last year in Bioscience. And it was based on a survey that we did of community-based monitoring programs. And we sent an invitation to 28 programs that had global representation. So it wasn't just based in the Arctic. And 18 programs returned the survey. 7 of them were from the Arctic, or were Arctic based. And the context is that we really wanted to understand the role of digital tools in managing data from community-based monitoring programs. We saw the sort of movement towards digital data management that's happened, across the Arctic in all disciplines, as also really influencing and impacting the way that community programs were collecting data, and then we're stewarding data and sharing data. And so we wanted to get a better understanding, sort of at a much more nuanced level of what that looked like. So some of the things that we learned, and I'm going to try to focus on what we learned that's really relevant to the use context and the development context for developing software and tools. But as you'll see from this presentation, and you probably can already see from the framing and the introduction, ELOKA really thinks that our approach is to think about the development of software in a much broader context, and really originating from the requirements and needs of community members and their real active involvement in platform development. But also increasingly, we're really focusing on the use context and trying to understand how we can shape these different tools and platforms to really ensure that they're usable and that they're sharing information in a way that's really relevant. So I think that's really the topic that we're trying to focus on today. So what we learned from the survey about the use context, first of all, in terms of the goals that the programs had in adopting different platforms, the top goal was improving information for decision making. And other top goals were systematizing observations and broader communication with outside audiences, as well as social learning, which we sort of defined as sharing information within communities or between communities at the community level. And then when we asked about intended users, researchers were the top intended user, followed by local decision makers and individual community members. And I just sort of want to point out here that there's a mismatch, a bit of a mismatch in the fact that the top goal was improving information for decision makers, but the top intended user was researchers who don't tend to be decision makers. So I just thought that was sort of interesting, and we can talk maybe more about why that might be later on. We also saw that the programs were using a spectrum of software tools, ranging from Microsoft Office Online to some tools that have been, some platforms that were designed specifically for citizen science and CBM data management, such as one that's called citsci.org, short for citizen science. SIKU is another Arctic specific platform. These are platforms that are intended to be multi-program platforms, so they could be adopted by different community-based monitoring programs. And then we also saw a number of projects that were developing their own custom designed software tools, so that those were very highly customized. And then finally, we also saw that a number of programs said that they used multiple tools, including social media. So Sea Ice for Walrus Outlook mentioned that for their users and community members in particular, Facebook was a great way to share information. So they had multiple platforms that they used in order to both collect and share observations. The capabilities and functions that people described sort of wanting their platforms to have and selecting platforms based on sort of at a basic level, data and metadata storage and organization, including searchability, ability to download and export data. Another top priority was integration with handheld devices for remote data collection, and a number of programs talked about the importance of having offline capability for both sort of viewing and entering data into these devices. And then another capability was the protection of sensitive data. So, you know, there are different ways that platforms sort of tried to protect data, and that programs interacted with platforms in order to do this. So in some cases, it was a matter of aggregating data, making general reports that they made available. In other cases, the platforms themselves developed tools like password protection or having tiered access. So some subsets of data was accessible to only to the community members, and others would be accessible to the general public. Another function was interoperability. So, you know, just under 20% of the programs said that the platforms they used were fully interoperable. So that was an area that was sort of flagged as in progress. Most of them said they were aiming to become interoperable. And then finally, multiple language support, including support for Indigenous languages. And notably, the Arctic programs had a much higher emphasis on having the translation and availability of accessing the database and using it in multiple languages, including Indigenous languages. But only one of them had system functional text available in an Indigenous language. So meaning that all aspects of the data platform were translated into that language. Some of the challenges that that programs had and that we discuss in the article, and here I'm sort of breaking them down into technical challenges and social challenges, and the majority of them have both technical and social dimensions. So one of them is, you know, probably fairly obvious. Jonathan already mentioned this in his introduction, a gap in digital access. And, you know, this is an issue that most of us are aware of in the Arctic, that there's very uneven access to the internet, that it's very expensive in many places, many communities. And so if you're managing data and sharing data online, this can be a real problem, especially if your main intended audience is Arctic residents. So let's see, I noted here that almost all of the survey respondents said that they had limited, that internet access limited the ability of community members to use their platform. And for half of the respondents, it was significant or very significant limitation. And in some cases that impacted the design of the platform and who the intended user was. Other areas, other challenges here are in technical capacity and digital literacy. So, the ability of communities to host the kind of the servers and host and add to and adapt the technology, the software tools, and to sort of do that themselves versus having that work be done, in partnership and in consultation with communities. There was only one of the platforms that we surveyed, which was the ELOKA program, that said that community members played a role in the technical maintenance of their platform. Other challenges, one was just that on the one hand, a lack of awareness of available software tools, and particularly, sort of at the community level. And then on the other hand, and perhaps this is related, seeing a proliferation of different tools being developed, but without a lot of coordination across those different tools. And that also relates to this question of interoperability. Another piece that was raised as a challenge is sort of implementing interoperability. So that was a goal that a lot of platforms had, but they hadn't fully implemented it. And I was going to see if Peter would be willing to chime in here, because I know Peter has worked a lot more on interoperability. Do you want to just say a few things, elaborate a bit on this, Peter?
Sure, thanks, Noor. Yeah, I think the part of the challenge of interoperability is it's a vague term. People use it a lot, but it's not always clearly defined. So at some levels, people are achieving interoperability, simply being able to share data between platforms and so on. But if we think about things like the FAIR principles, which some of you may have heard of, findable, accessible, interoperable, and reusable, when you look at the details of those models, the interoperability requires more than simply opening up your data set. It requires things like actually being able to understand the data. And if you're going to reuse it, that's more than just even understanding perhaps the terminology used, but thinking about the provenance, how the data was collected, data quality, all these other things. And so this is where at some level, many people are thinking about it and some people are doing it. But going to that level where you can truly interoperate and truly reuse the data takes a bit more, and it can be costly and time consuming and quite complex. That said, more and more people are interested in starting to build it into their workflows. So I think we're seeing a lot of movement on this in a positive way, not only in our research community, but in the broader community with local Indigenous communities and elsewhere in the Arctic.
Thanks, Peter. So yeah, a few more challenges. One is, that we highlighted in the article is data ownership and protection of sensitive information. Some of this is sort of thinking about the sort of broader legal framework and context for data ownership and data sovereignty, and then how in practice these tools can be designed to help support that. To support the implementation. So, Peter mentioned the FAIR principles. The CARE principles are, a set of principles that are designed to think about this sort of ownership and social context, but actual implementation is still sort of being worked out. Another technical challenge is just the maintenance of the software. So I mentioned that there are a number of different custom tools that are being developed. Often those are developed under a grant that has a limited time frame. But if they're going to be used beyond the time frame of the grant, then they need to, more resources need to be found to maintain and upgrade the software. And then the updating and maintaining the information. So that's sort of the data aspect. That sort of needs to be continuously updated in order to keep these software tools and platforms relevant and useful to Arctic residents. And then finally, related, linking the tools to the information needs and the use context. And a lot of times that can change over time. So it may be that there was one use sort of identified at the beginning, but then other information needs may become clear, and there's an option to adapt the tool to meet those other needs. So being able to sort of shift and have the software be flexible enough to meet changing user needs is another challenge that we sort of discussed a little bit. And I think that might be clear as we get to the examples that we're going to share. So just a few examples. This is, I included this example just to show one way that the software tool that we developed at ELOKA, the AOK database, which shares observations from local observers in coastal communities in Alaska. This is in order to access the observations, we include a use agreement, and we ask the users to acknowledge the knowledge holders and to try to understand and acknowledge the context that the observations were made in. So this is just one example of the ways that these tools can address some of the concerns about data ownership and data sharing. Another example is a platform that we have been working on with the Chillista Education and Culture in Alaska for about 10 years, 12 years. This is an atlas that shares place names, Yupik place names, and it was developed initially through a collaboration with Chillista Education and Culture, but over time we identified another partner, the Lower Kuskokwim School District. They've adopted this atlas to help with teaching Yupik as part of their curriculum for middle school age students. And so that's an example of how the use context has evolved for this particular tool. And we've had to do a lot of work to kind of think about how to support that use and developing videos and tutorials so that people who are located in the teachers and others in the classrooms can help students add place names and other observations to the atlas. And then another evolution, very recent evolution of the atlas is that we're working right now to add climate data to the atlas. And the use context is, for this is that, first of all, the schools are interested in having this as something that they can offer to supplement the curriculum and make the atlas sort of usable in other disciplines and other classrooms, so not just in Yupik language teaching. But the other context is just that it will sort of broaden potentially broaden the usefulness of the tool so that people who are doing like land use planning, for example, and other decision support roles will be able to look at the place names on top of different kinds of climate projection data and information. And one of the challenges and also the sort of, I think, pleasures of working on this particular module of the atlas is that we're really trying to think about how to present the data in a way that is understandable and that makes sense to use sort of a term that Jonathan shared earlier this week, sense making, that it makes sense within the worldview of Yupik. So we're thinking about, for example, how can we ask questions that might invite people into the data, such as how may increasing temperatures and precipitation affect berry harvests? So something sort of practically oriented that could invite people to come and explore. And then another piece is just, that we've been thinking about in terms of how to introduce this is that Yupik think about prediction in a particular way. So my understanding is that, that it's not a good idea to predict anything with certainty, that's not really the way that doesn't fit within the Yupik worldview, but that if you talk about possibilities, that is a better way of framing projections into the future. So this is all to sort of say that sharing information and making it useful for community members of the Arctic really requires a lot of collaboration, a lot of communication, and a lot of sort of continual back and forth to make sure that information is being presented in a way that really meets the use needs and also fits the social context and makes sense in the context that you're trying to share the data in. And then I'm going to ask Peter if you would just talk about the Clyde River Atlas a little bit.
Sure, thanks, Noor. So the Clyde River Atlas was developed or is being developed by ITAC, a group in the community of Clyde River in Nunavut, Canada. And I think it's a particularly interesting product, interesting tool and platform in that right from the outset, it was developed by the community. So the community came together and decided that they wanted to establish a system like this. They put together if you go to this site, actually to the homepage, you'll see images of the steering committee that actually guides the development. So Noor has it there as well. And so right from the beginning, the community is deciding, what they want to do, how they want to do it, the different themes that are in the Atlas and so on. Noor, if you could just go back to the other slide. So for example, the Nunavut Coastal Resource Inventory was actually carried out in partnership between communities and the Nunavut government some years ago. And there's a really, really rich collection of wildlife and species information that were collected from community members. So this is one of the modules in there. You can go in and see hundreds and hundreds of different observations. And this is now actually being continued by the Nunavut government in partnership with the communities to monitor and use this as a reference data set. But there are many other modules in it as well. Their latest work is being done more of a monitoring approach using Garmin InReach devices. And these are devices that can actually provide real-time monitoring. So they can, within a few minutes of the observation, be pushed up through the Iridium satellite network and then brought back down to the Atlas through what's called the Who's Out module. So this is still under development, so I can't give you a screenshot of that right now, but it's actually just been tested in recent months and weeks. And so these are the types of things that this particular group, and if you're interested, you can contact ETAC. It is their product, but I and others have been involved in helping to develop it. And that's also an interesting model. It wasn't a model where researchers or people from the private sector came in and said, what do you think about this? As I said, they developed the concepts, they actually raised the funds, wrote the proposals, got the funding, and then went out to partners and said, we would like you to come in and fill this role in the project. So I think this is a good example of the types of things that we're seeing, and I think we'll see more and more of going into the future.
Great, thanks, Peter. So I think actually that is the end of our presentation, and yeah, we wanted to sort of leave you with those examples. And I think the Clyde River Atlas is a particularly good example because of what Peter just described, that community members were really leading the development and have been really involved in all aspects of the design and development of that tool. So, and I'll just end by thanking the National Science Foundation for their support, for ELOKA for their ongoing support. I think I will stop my screen share. And Jonathan, did you want to have discussion now before moving on to the tech update?
We might as well take any questions directly related to the presentation. And I think after David Arthur presents it, that'll be a 10-minute presentation roughly. We should have more time afterwards if there's any other questions for you, Noor, or about directly to David's topic, or also anything in between. Anne? I see Ann Jackson has her hand raised. Do you want to speak?
Hi, yes, thank you. Data collection from a local level using technology Is there any differences you see data collection from Indigenous peoples themselves? Is there any differences compared to whoever else?
Are there differences in how Indigenous led projects are collecting data? Is that your question, Anne?
Yes, yes.
I think that's a good question, and many others on this call would have their own take on this question. And I think at ELOKA we include a lot of different types of data formats in the atlases and other things that we put together. So, everything from audio files to video files to sort of narrative descriptions of what is being observed to, sensor-based data. So I think that, when we're talking about community-based observing and monitoring, that there might be a broader range of how data is sort of collected and documented, including more sort of narrative formats of observations. But others may have another thought about that as well. That would be a difference that I have seen. Anyone else want to share a reply to that question or have a different thought about it?
I might just say, Noor, I'm following on your comments, is often the acts, in my experience working with communities, may be very similar. The tools that are increasingly being used, maybe GPS units, cell phones, et cetera, but the drivers and the sort of rationale behind the observing comes from generations, millennia of knowledge. So it's not strictly, we have a scientific protocol. It's, what does our knowledge tell us going back many, many millennia, as I said, and how does that inform, what's being observed, how it's being observed, and so on. And then also the reasons for it. So there may be very different reasons than we would have from, the research community as to why those observations are being made, whether that be for, management processes, but also things like cultural reasons, language revitalization, and all kinds of other things. So I think it's a bit of a Venn diagram, as there's some similarities, but there's also some differences.
So you get a different perspective, but a very helpful one at that.
Yeah.
Well, sorry.
Well, no, I just was going to say I appreciate those 2 points that you just raised, Peter, and I think the first point you made about how some of the data collection methods are the same, and even if an Indigenous led or a community led project may be using, for example, a sensor to collect information in a similar way that a scientist might, but the community, at least some knowledge holders in the community would have a much broader and deeper context for understanding or situating those sensor-based observations. So it would be sort of a real different way of they might interpret them differently or just describe the context quite differently.
And that question, we can revisit that after David Arthur's talk. They may he might have additional thoughts to present through his work. Are there any other questions for Noor's presentation before we go on? Okay, not hearing any. David Arthurs is joining us. He's the managing director, that is, for PolarView. Correct me if I'm wrong, sorry. But I'll let you introduce yourself, please. Thank you for joining us.
David Arthurs, Managing Director of PolarView. So I don't know if people are familiar with PolarView. In short, we're a not-for-profit organization representing organizations interested in polar monitoring across pretty much Europe and Canada from the public, private, and academic sectors. We've got about 25 members. I think at the start you talked about my role here as a vendor, which I initially bristled at because we're not here to sell things, but doesn't mean we don't charge for things. So I guess I'm a vendor in some ways. Just to position what I'm going to talk about in this broader conversation, as you will hear, we're mostly a processing engine. So we do the data processing, and we would work with platforms like Noor talked about and Peter, and we're actively working with them now to act as the processing engine behind some of those platforms. And what I'm going to talk to you about, which is called PolarTep. This is the latest version of something that's been going on now for 6 years. It's operational, but we're still in this newest version, sort of shining it up. So we're not out actively marketing it. If you're interested, we can provide you with the capability, but I'm not actually presenting the URL and saying, go here and sign up quite yet. So I will start the formal part of the presentation. Hopefully you're seeing a screen.
Yeah, we can see that. Thank you.
Okay. So I'm just going to give you a quick introduction to what this is all about, talk a little bit about the architecture and the capabilities, and spend a little bit of time on a use case which demonstrates the applicability of the platform to real life experiences in the North. So, introduction. The elevator pitch. PolarTep is in essence a virtual research platform. If you're familiar with things like Google Earth Engine, we're not dramatically different, other than we're focused on the polar regions. So we provide data and services and algorithms which are focused on the needs of polar research, northern residents, and operational uses. But we're very much part of a wider polar data ecosystem. So we do some things really well, and we work with others in what they do well. Mostly we provide access to data, and in particular, big data. If you got a small data set, we may be overkill. We grew out of the Earth observation world. We also deal with large data sets from models and things like that. And the idea is that we provide the data and computational resources and all of the analytical tools you'd need. And we do that in the cloud, so you don't have to have your own very capable computing resources. And especially if you live in a region with low bandwidth connections, you can do the heavy lifting in the cloud and reduce the data interaction with your own system. We're here to foster data discovery and interoperability, as Noor and Peter talked about, and we're very much in favor of collaboration and community building. And we do all of this to foster understanding and improve decision-making. So what's a virtual research platform? We are a creature of the European Space Agency. Since the idea of these thematic exploitation platforms started, many other organizations are now doing similar things. But the idea is that especially with Earth observation data, the explosion of the volume of the data and the speed at which it's changing means that the traditional model of downloading data is broken. So our mantra is to bring the user to the data. As I mentioned, we're very much part of a wider ecosystem. This is just a quick schematic of the organizations we deal with on many levels. Some of them provide us with technology, some with data, some with tools, some are heavy users. And it's all about fostering international collaboration, supporting safety of life, supporting northern communities, and supporting environmental protection. I'm not going to go much into the technical details of our setup, but just a sort of brief overview. We're very much infrastructure and data agnostic. So we mix and match components to meet user requirements, and we subtract and add components to maintain state-of-the-art capabilities. We started off by writing our own code, and that quickly went out of date, and we couldn't maintain it. And we're finding this works much better, this new philosophy. So we're open to working with any data service or component provider. You may recognize Peter's famous diagram here, but just to say, again, to emphasize, we're part of a polar data ecosystem, and we like to think of ourselves as one of the central hubs. So big data comes in, analysis goes out, and we work with others on both ends. I mentioned that we build on components. Currently, our main platform offering is based on something called the Euro Data Cube, which is a bad name because it's a lot more than a data cube. But this is a European capability that provides data cube plus data searching capabilities plus virtual machines and things like Jupyter notebooks, etc. We can do Docker containers and all of that. We have a machine learning platform that's proving very popular, and we all sit on top of a DIAS, which is a European platform for access to, in particular, the Copernicus data. So things we do, data access. I mentioned we're about big data. We have access to currently over 25 petabytes of satellite and other analysis-ready data. You can read the different sensors that we make use of. Analysis-ready data comes predominantly from the Copernicus services. And if in all of those petabytes you don't see what you want, you're fully able to bring your own data. We're big on data interoperability, of course, because we actually prefer that others hold the data. We can be a data repository, but it's better if the people responsible for the data hold it. So we're fully interoperable using OGC services. We're increasingly getting into OpenDAP type things. And we have connections to the major polar data repositories. Then all of that data, our purpose is to process it, and we have various levels of capability to do that. The level you would choose depends on how sort of computer savvy you are, whether you know how to program, but also how data intensive the processing is. So on the left side is the easy way, where we've got an algorithm that's pre-canned into the platform. And you just put in some parameters and click and you get a result on the fly. A little more sophisticated, you can get into simple JavaScripts. Most of our users are at the Jupyter Notebooks level, so they know something about Python coding and they can do their own programs. If you're getting into really massive data processing, then Jupyter Notebooks is a little bit too much overhead, and you can put it in a Docker container, and that's where we do the heavy lifting. I mentioned machine learning. We have a state-of-the-art machine learning platform called HopsWorks. It manages the complete data lifecycle from training data preparation through experimentation and model training. And you can run multiple iterations of your training, optimize your algorithm. Once you have an algorithm you are happy with, you put it back into the execution environment of the main PullerTech platform for operational use. We do data visualization, so you can see some fancy graphics here. On the left, it's just a fly through and a 3D globe. That's actually Tromsø, Norway. And on the right is an animation of successive Sentinel-1 images in the Baltic Sea, showing the evolution of sea ice. So I wanted to just then focus a little bit on one use case. As I said, we support uses by northern communities, polar operations such as shipping, and then polar science. The use case I'm going to look at is in the northern community area. Polar View has been providing a community ice service now in the Canadian Arctic for 20 years. And this supports traditional ways of life and Inuit hunters going out on the ice to travel between communities and to hunt. Increasingly, climate change means that traditional knowledge isn't as useful as it once was. So we provide this, quote, space age technology to assist. The way we used to do it, we'd have a human analyst look at each satellite image and analyze it. And that was very labor intensive and slow. And of course, that ultimately makes it expensive. So that wasn't really sustainable. So we've now developed some sophisticated data analysis techniques that allows us to automate that process. We're currently using the automated process in 4 communities. Just a hiccup is we use Sentinel-1, and you may have heard that Sentinel-1 has 2 satellites. One of them stopped working, which is causing us great grief, but that's hopefully a temporary problem. So what do? We provide people in the north with, first of all, the satellite images, and they find these really useful. They're good at interpreting them because, of course, they know the ice well. So they know what real life is like, and they can correlate that with what they see in the image. So that in and of itself is of great use. We then do some sophisticated analysis that determines where the ice is moving quickly and where it's not, and that determines the flow edge. So in this diagram, the boundary between the red and the not red on the sea ice part is the flow edge. And this is where people want to go to hunt, because this is where most of the biological life is. You can just translate that then into a landfast ice area. So on the right is mobile ice, and on the left is landfast ice that theoretically you could travel on. But even the landfast ice is not always completely safe. For example, you get tidal cracks and plinias. Using INSAR pairs, we can sort of analyze 2 images and pop out the cracks. And this is a sort of new state-of-the-art thing we're working on. But at the top here, you can see the satellite image and then what it looked like in real life. And on the left at the bottom is just a single SAR image. And on the right is one that's been enhanced to show the same area, but sort of having the tidal cracks show up more clearly. And that's it.
Thank you very much, David. So any questions for David's talk? Lisa?
David, I'm kind of blown away by that last image you just showed of the tidal crack enhancement and how it looked like it was mostly open water, and then you enhanced it and you could really see the ice and the cracks there. So that was really interesting.
Yeah, we're pretty excited about that. It's sort of in the R&D stage, but we've got there's an organization in Canada called the Weather Network that produces gives most Canadians their weather, and they're interested in providing that as one of their data feeds. So we're working with them on that. Oh, I should say that what you've seen there, we're also extending to Greenland and to the Baltic Sea. So if Alaska has any interest, we'd be happy to talk.
See, there was a vendor pitch in there. So I was interested to see you have points on the map. These are the communities you serve. Does that mean that you have a local analysis, a higher resolution for them?
We focus on communities and in the area that a community would travel over. The processing is quite intensive, so we don't just do a background of the entire Arctic. We do it in areas that there's a demonstrated need. So first of all, you need sea ice. So, obviously we only do it where that makes sense. And then you need a community that actually goes out and travels on the ice. And then there's no point in doing it where people aren't traveling. We used to do it in 32 communities, but we still provide the satellite images in those 32, but we don't actually do the analysis of the images because it just became too basically expensive. But with this new automated technique, we hope we can go back out to all 32, plus Greenland, plus Baltic Sea.
Great. Yeah, that was a great presentation. Thank you, David. And thank you, Noor. I think, there's a few themes that I hope we'll be able to touch on repeatedly that were highlighted today. One is for, there was a point about, there's several challenges Noor highlighted, but one I picked out at, well, maybe at random is software maintenance. That's the challenge that we have often is when we invest in a platform, that investment pays for the initial development, but then as a community, we have to find ways to maintain that platform. And that can help us drive decisions on whether to pursue open source or commercial software. Another topic that came up was on accessibility. And by this, I mean like limited bandwidth or the technical literacy or digital literacy. And one of the principles in technology development is when you make technology more accessible to these use cases, these specific people who have specific technology challenges, you actually improve the technology for everybody. So that's the continued focus I'll highlight. Now to Polar View, cloud computing, processing data on the cloud. This is a great opportunity for us, and Polar View is exploiting this, of course, to the fullest extent, bringing big data, large data sets and tunneling them because the processing is being done on the cloud, tunneling just the analysis portion specific to that community. So that's really a low bandwidth product. You don't need to pull in all those terabytes. And then something I hope we'll be able to speak to more, and there was just touched on with David's talk, is the machine learning. I think that's a huge new topic for us. And in particular, I'd be interested in the merging of these two topics, the traditional indigenous knowledge, machine learning between that and the the big scientific data sets, because I think there's some negotiation that a machine can do that might help deliver this information in more timely, relevant fashion to the end users. So that's my quick synopsis of the meeting and highlights. Is there anybody else with a question or a comment that you'd like to give before we sign off?
I just might quickly support what you said about maintaining the software and the observation, which our community is well aware of, that the funders always like to fund shiny new things, and they don't want to maintain what somebody else originally paid for, which propagates this issue of reinventing the wheel every time. So I know we all live with that.
Yeah, that's a recurring topic. Okay, Chris, one last comment, please.
Yeah, thanks. New to the group too, so I appreciate. Sorry, I came a little late. This is super interesting. I'm helping build a digital archive for NUPET community from Virginia Tech, and this has been super helpful to listen about others struggle busing through some similar issues. And I had a question that I originally wrote for the first presentation, but I think David can probably speak to it too. And I'm curious about the role and how you've been engaging the communities with testing and developing these tools. That's something that we're going to start doing this next year in our project. It is Inuit led, so it is community focused and community led, but we are helping roll out this digital archive. So I posted my question in the chat, but I'm curious about what lessons learned, I guess, you can offer with regards to engaging the community, what that looks like for you and throughout the development process.
We've been in,
Sorry. Chris, was your question for David or for me or for both of us?
I think, for everyone who presented, I feel like it's probably something that can apply across the board. So I would, any lessons learned, I would love to hear.
Okay, if it's okay, I'd love to go first because unfortunately I have to run to another call. But I would actually love to invite you to just get in touch with me. Maybe we can find another time to talk.
Definitely.
I would say ELOKA has done this in different ways, but we work in partnership with usually an organization that coordinates with community members. So we're sort of one step removed from the community. And so we have done it often by sharing and presenting to, for example, for the Yupik Atlas, we've presented to the Elders Committee that helps guide the Chilista Education and Culture and gotten feedback from them sort of at many stages in the development and iteration of that tool. And we've also tried to get feedback from teachers who've started to use it. We've done that most successfully in person. So I guess the one tip I would say, which may be obvious, is it's a lot easier, like if you're in the community, to get feedback than it is in a virtual environment. So the last couple of years have been a little bit hard in terms of getting feedback, but I would welcome having a longer conversation and would be love to learn more about your project. So thanks.
I would love that. Thank you so much. I sent you my email in the chat too, so awesome.
On our side, we've been working with communities for 20 years. So we do have some communities where we have local people who, are test it for us and act to give us feedback. Having said that, I think the issue at the moment is that the communities seem overwhelmed with people wanting to help them, and there's not a lot of bandwidth left. So we've had examples where we, had opportunities for funding. All we needed to do was involve the community, and all the communities we contact just say, look, we're really tired. We don't want more stuff. So that would be my personal experience with the biggest impediment at the moment.
I've heard the same thing from the community we're working with, especially researchers coming up during subsistence periods of time. They get really annoyed, right? Like, oh, you're back again. And so yeah, we're trying to be sensitive to that same issue. Do you have you started to think through that problem? We've been talking with the community with regards to how to make it much more of a rich experience, to kind of highlight how it's not just this kind of industry-based approach to research of like, okay, sit down, do this task, we collect data, but how one community partner had this great idea about like a Stitch Fix survey, or like, you know, Facebook surveys. So we're, as a technical communicator myself, I'm trying to come up with some more new, you know, community-oriented fun ways of doing the research too. But that's just one thing we've been toying around with in our heads.
I see Anne has her hand raised.
Hi, has there been approach to have a older person, a younger person, being that younger people are more tech freaks than the older ones, and that way you have younger ones at the same time learning land-based teachings, reading the land, reading the animals, reading the trees. I think that would be a strong approach, getting these, whether it be elders or older adults and young people, to work together both ways. I don't know if that has been tried. If it has, let's hear about it.
Just to say, I think this is related to your comment that we used to, our products 20 years ago, we would have them printed out and posted in the Hunter and Trappers Organization hut, where the community would go in and look at it. And I was up in Pond Inlet a number of years ago, and as I stood there, a young hunter came in and pulled down the piece of paper and took a picture of it with his cell phone. And that was his way of getting the information out with him, was a picture on a cell phone. And that, for me, that was an aha moment. Like, we've got to catch up with the young people in the North, because they're moving to more sophisticated ways of dealing with this information. Now, that in retrospect seems obvious, but at the moment it was a sea change for me. So I guess what I'm saying is the training goes both ways. It's not just the elders who can train the young people. The young people can train the elders too.
Right, this is a really nice discussion, and I wish we could spend the rest of the day talking about this, but I think for respecting people's time, thank you so much, David Arthurs, for coming, Peter Pulsifer and Noor Johnson for presenting to us. And let's look forward to more discussions like this. We'll put, next meeting, we're not going to be covering this particular topic. We're going to be dancing around different technology issues. But coming up in 2023, we're definitely going to revisit this topic, and we'll let you all know through the IARPC channels and our respective networks that we'll be revisiting this. So thank you very much. Thanks for a great meeting.
Thanks, everyone.